All right, so in this video, we're going to continue talking about similar figures, and in all these problems, we're going to assume that the figures are similar and that we're going to use what we know about similar figures to find the missing sides. So if you look at this first problem here, you can see that the sides given are 25 and 50, but in the second triangle, X is standing for the side that's missing. We don't know what the value of this is. That's what we're trying to find. All right, so we want to do that by setting up a proportion, because we know that similar figures have proportional sides, or corresponding sides, sorry, are proportional. So I'm going to start with my word ratio. A couple ways I could do this. I could try to use the first triangle and just do the short side to the long side. So if I do it that way, I'm going to use short and long and set up my boxes. And again, I like to circle the corresponding side. So I know that 25 is the short side and 50 is the long side. And then in the second triangle, I'm going to circle the short side, which is X, and I'm going to box the long side, which is 10, so that I put those in the right spots. All right, so once I have a proportion, then I'm going to use my cross products in order to solve it. So I know that 25 times 10 is equal to 50 times X. 25 times 10 is 250. I don't know what X is, so I can't multiply these. So I'm going to work backwards and divide instead. So if I divide 250 by 50, it will go 5 times. So that's telling me that X is 5, and then the unit for that is going to be inches. So 5 inches. This is the value. All right, if I move on to the next example, another way I could set up a proportion rather than doing short to long side is I could do the large rectangle and compare it to the smaller rectangle. So a couple ways to do proportions. Just make sure you get your corresponding sides matched up together. All right, and then I'm going to draw my boxes. All right, so in the large rectangle, if I pick the side that starts with E, the corresponding side in the small rectangle is the shorter side. Look at how they rotate it. The rectangle, don't let that fool you, and make sure you're going with corresponding sides. So since these are both the shorter side, they're corresponding, so 8 to 4. And then I'm going to go back to my large rectangle and use the 12, and it's corresponding with the longer side here, which is X. So once I have my proportion, I'm going to find those cross products again. 4 times 12 is going to equal 8 times X, and then multiply those. That gives me 48, and then I can't multiply 8 times something I don't know, and so to find that, I'm going to divide 8 into 48, and that will go 6 times. So X is going to equal 6, and this is in miles. Okay. And just to show you that there's more than one way to set up a proportion, I'm going to redo this problem, but this time instead of doing large to small, I'm going to do kind of like what I did in this first problem, where I take the short side and compare it to the long side. And I just want you to see how there's more than one way to do this problem. So if I do short to long, I'm starting with the first rectangle, and that would be 8 over 12. And then I'm going to switch over and do short to long again, so 4 to X. Notice that they have used the same numbers, but the proportions are slightly different. However, when I do my cross products, I still get 12 times 4 equal to 8 times X. And so when I multiply 12 times 4, that's 48, equal to 8 times X. And then to solve it, I divide again by 8. And again, I'm going to get 6 as my answer, and it's still miles. So once again, the proportions were slightly different, but as long as I keep corresponding sides together, I'm going to end up with the same solution. So for this last problem, we're solving actually for 2 unknown values. So when that happens, in a proportion, you can only solve for one variable at a time, which means if I'm going to solve for 2 different things, I'm going to need 2 different proportions. So in order to do that, I want to start by setting up a proportion using sides that I do know, both know. So I can see this is actually a trapezoid this time. And the 2 sides that I have for both of these trapezoids is this top length here. So I know that I'm going to use that in my proportion. So let's do maybe the large trapezoid compared to the small trapezoid. So my first proportion, the large was 5, and then the small side was 2.5. And then, since I'm trying, in this first time, let's go ahead and try to solve for x. So if I'm solving for x, then the corresponding side is 8. So I'm going to do, for the large one, 8, and for the small one, x. And then this is the proportion I'll use to find x. So I'm going to multiply 8 times 2.5 and find out what that's equal to. 5 times x. I didn't put the dot here because when you have a number written right next to a variable, that also means multiplication. Remember, there are multiple ways to write multiply. This is just another one. But if you like the dot, you can put it there. 2.5 times 8. So 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. Don't forget this decimal here, 1 decimal place, so 1 decimal place here is 20. I don't have to keep the 0.0, so I'm just going to use 20 is equal to 5 times x. Then to solve this, since I don't know what x is, I'm doing the opposite. Instead of multiplying, I'm dividing. 5 will go into 20 4 times, so x is going to equal 4 centimeters. So I'm going to go over here and write 4 centimeters. All right, so now I'm going to do the same problem, but this time I want to solve for y. So in this case, I'm going to ignore what I used for x. I'm going to go back and use those top sides again, but this time I'm going to use the bottom sides so that I can solve for y. So new proportion, I'm still doing large to small, so I'm going to start with 5 over 2.5, and then I'm going to set it up using these bottom sides. So the large trapezoid is using 10, the smaller one's using y. It's a new proportion. I'm going to solve it the same way though. 10 times 2.5 and 5 times y. All right, so when I multiply 10 and 2.5, 5 times 0 is 0, 5 times 1 is 5, start with a 0. 2 times 0 is 0, 2 times 1 is 2. When I add these up, make sure you don't forget about your decimal place. I'm going to move it over one place. This is 25.0, which is the same thing as 25. That's equal to 5 times something. So if I don't know the answer to this, go ahead and divide. 5 into 25 will go 5 times. So y is going to equal 5, and then I'm still using centimeters, so 5 centimeters. 5 centimeters. All right, so again, we're using proportions in this video to solve problems that have missing sides. When two similar figures are being used, you can use what you know about their corresponding sides to write a proportion and then solve. All right, so good luck with that. Thanks, guys.